plugging into this relationship, so here's our XY relationship. It's our relationship shown in an equation. Okay, this relationship can also be shown in a table, which we're going to fill out this table with. So be careful of that negative there, because we're going to end up with some double negative calculations. So be careful to keep track of that. So when we plug in -4, we get negative times negative, which is +8, minus 3, which is +5. Okay, so again, be careful of those double negatives. So -4, +5. So there's one point on that graph. -3 is going to give us +6, minus 3 is +3. So -3, +3 is going to be another point on the graph. So there it is. -2 times negative is positive, minus 3 is 1, so -2, +1. So -2, +1. So at this point I can kind of see this pattern. It looks like I'm going down by 2s, down 2. So if I go 2 to the right, I should go 4 down. So I should end up at -3. So let's just double check this. So plugging in 0, 0 times anything is 0. Minus 3 is -3, so I was correct. It goes down. It looks like it's going in a straight line, and the straight line seems to be characterized by this ratio of 1 over 2 down, 1 over 2 down, 2 over 4 down. Okay, and so plug in 1, I get -5, 1, -5. So 1 over 5 down is going to be right there. And that's something that we should kind of note, is that these straight line patterns, okay, so this is another straight line pattern that I found, they seem to have this constant ratio of change. So it kind of goes down by constant steps. And that makes sense, because if we're talking about stairs, if it went 2 down, 1 over 2, 1, 2, 1, 2, 1, if we had constant steps like that, it would go down, and we would be going down in a straight line. And that's what characterizes then these straight line equations. It's something called slope. Okay, and this slope can be measured as an angle, but it could also be measured as a ratio of two sides here, going down and across.